What if we have some numbers that are given to us in scientific notation, and we want to do arithmetic to them? In particular, right now, I want to talk about the arithmetic that we're doing as addition or subtraction. So I'm just going to pick out two numbers that are in scientific notation. 6.142 times 10 to the negative 7th plus 3.108 times 10 to the negative 7th. Now, you're probably thinking that I didn't choose those numbers entirely at random. And you're right. I chose these numbers intentionally to have the same magnitude. And when that happens, when we see two numbers that have the same magnitude, well, notice scientific notation is put together using multiplication. We have a rule that tells us how multiplication and addition interact, and that's the distributive property. So this number times 10 to the 7th plus this number times 10 to the 7th is what we get if we add together the two numbers and multiply by 10 to the negative 7th. So just for the sake of an example, I'm going to do this addition by hand. 6.142 plus 3.018. Add them up. 10, 6, 1, 9. I get 9.160 times 10 to the negative 7th. Okay. Notice I left in that 0 because that 0 is significant. Now, occasionally, it's going to be necessary to fix the scientific notation. So why might that happen? Let's say I'm subtracting 2.93 times 10 to the 4th minus 2.02 times 10 to the 4th. I'm going to subtract the significans. 2.93 minus 2.02. 3 minus 2 is 1. 9 minus 0 is 9. 2 minus 2 is 0. I get 0.91 times 10 to the 4th. But that's not correct scientific notation, right? This significand is too small, so I need to fix it. 0.91 is 9.1 times 10 to the, this is the negative 1 place. So I have 9.1 times 10 to the negative 1 times 10 to the 4th. Add the exponents and I get 9.1 times 10 to the 3rd. Okay, what if I don't have the same magnitude? Let's say I wanted to add 3.71 times 10 to the 5th plus 7.4 times 10 to the 3rd. Well, if I don't have the same magnitude, I need to rewrite so that I do, or else the distributive property isn't going to apply. Now, we can pick whatever magnitude we want for this, but we'll have less fixing of our scientific notation to do at the end if we always choose the greater magnitude that appears in the problem. So here, my greater magnitude is 10 to the 5th. So I'm going to rewrite my 7.4 times 10 to the 3rd as 7.4 times 10 to the something times 10 to the 5th. What power of 10 do I need to multiply by 10 to the 5th to get 10 to the 3rd? What plus 5 is 3? Well, negative 2 plus 5 is 3. So I get 7.4 times 10 to the negative 2. 7.4 times 10 to the negative 2. That's, let's see, 7, 4, 1, 2 places to the left. I have 0.074 times 10 to the 5th. Again, that's badly formed, but now it lets me do my arithmetic. Right, I've got my 3.71 times 10 to the 5th plus 0.074 times 10 to the 5th. Add the significans. 3.71 plus 0.074. Right, fill in a 0 in the blank. 4, 8, 7, 3. I get 3.784 times 10 to the 5th. So, what are my steps altogether? First, I rewrite so that both numbers have the same magnitude. Then, now that they have the same magnitude, I add or subtract the significans, depending on whether it's addition or subtraction. And then, if necessary, I fix the scientific notation.